Hello and welcome back. Today we're talking about the elbow method. So here we have our data points, and as you can see, they're in 2 dimensions. I just wanted to say before we continue that K-means clustering doesn't necessarily have to work in just 2 dimensions. It can work in many dimensions, but for simplicity's sake, we're looking at 2-dimensional examples because they're easier to illustrate. So our data points are here, and we already know how K-means clustering works. The question is, how do we decide how many clusters to select in that very first step? Because it's up to us. Well, the elbow method is one of the approaches to help you make this decision. There are other methods as well. And moreover, sometimes you might already know in advance from your domain knowledge about the problem, how many clusters there should be or how many clusters you would like to have. But if that information is not available, then the elbow method is a pretty good way of finding the optimal number of clusters. So the elbow method requires us to look at this equation for the within cluster sum of squares, or the WCSS. Don't worry if it looks a bit complex at first. It's actually very simple. It basically looks at the distance between each point and the centroid of its cluster, and you square that distance. So let's have a look at this in an example. If those are our data points and we have one cluster, then we just need to measure the distance between each point and that centroid, square it, and add them up. If we have 2 clusters, then we need to do that for the red points on their own, calculate the distance between each point and centroid, square them, add them up, and then do the same for the blue points and then add them up again. And same thing for 3 clusters. So 2 things to point out here. First one is, as you can see, to calculate all these different within cluster sum of squares for the different options, we actually need the clusters to already exist. So every time we have to first run the K-means clustering algorithm, and then we calculate the WCSS. So it's kind of a bit backwards. We don't first do the elbow method to find the optimal number of clusters and then do K-means. We do K-means many times, find the WCSS for every single setup, whether it's 1 cluster, 2, 3, 4, 5, and so on. And then we will be able to apply the elbow method, which is coming up on the next slide. And the second thing to note is that the more clusters we have, the smaller WCSS becomes. You can even see it visually. So here the distances are high, and especially when you square them, the WCSS will be quite large. Then here the distances are smaller, and so the WCSS drops. And here again, the distances become smaller and smaller. And so we can continue increasing the number of clusters until we get to the maximum number of clusters, which equals the number of data points that we have. And then WCSS will be actually exactly 0 because each data point is its own centroid and the distance is 0. And so the chart that we can build from this looks like this. This is the WCSS, and on the y-axis and on the x-axis, we have the number of clusters. As you can see, it drops off all the way down to 0, as we just discussed. And the elbow method is very simple. It's actually a visual method. When you look at this chart and you look for where is the kink in this chart, where is the elbow? There it is. And so that is your optimal number of clusters. Basically, when the WCSS stops dropping as rapidly. Of course, it's a judgment call, and sometimes it can be unclear. There might be 2 potential candidates or more candidates for the optimal number of clusters. But then in those cases, it's something that you need to decide as the data scientist. So there we go. That's how the elbow method works. Hope you enjoyed this tutorial, and I look forward to seeing you next time. Until then, enjoy machine learning.